Correlation and Causation, a Stats 210 presentation by Mikayla Roach. What is a correlation? A correlation is the degree to which two variables are related in a complementary way. This means that the variables change together. When one goes up, the other goes up, or when one goes down, the other goes down. Examples of this include homicide rates and gun ownership. This is an example of a positive association. More guns equals more homicide. Other examples include temperature and heat bills. This is an example of a negative association. As the temperature decreases, the heat bills will rise. As well as the temperature increases, the heat bills will decrease. This is called an inverse or negative relationship. So what does a correlation look like on a graph? We're going to start with scatter plots. A scatter plot is simply a plot of points. Notice that I have drawn 3 below. These 3 scatter plots show 3 different types of correlation. In the first graph, the points show an upward, straight, positive slant as demonstrated by the yellow arrow. In the second scatter plot, these points show a downward straight slant as demonstrated by the downward facing arrow. In the last plot, the points appear to be completely random. As you can see, the first one is a demonstration of positive association, the second negative, and the third none. So, what does causation mean exactly? Causation is the act or process of causing. Simple, right? Think again. If something is correlated, that means that there must be causation, right? This is actually incorrect. The most important point of this lecture is that just because 2 variables are correlated, it does not mean that causation is present. So how do you spot causation? First, you need to try to determine cause and effect. And secondly, you always need to look out for a third variable that could be associated with the data. Determining cause and effect is very risky and uncertain because these third variables can have quite a large impact. Now we're going to look at an example of correlation without causation. The Science Creative Quarterly published an article that held this graph. The graph shows global average temperature on the y-axis and the number of pirates on the x-axis. It shows a positive correlation, which means that the lower the piracy levels, the higher the global average temperature. This proposes that piracy decreases the average sea surface temperature, thus lowering the average global temperature, which suppresses the tropical cyclone intensity. Overall, what the article is trying to claim is that the lower amounts of piracy is going to equal to higher amounts of tropical cyclone intensity. The article has a call to action at the end that claims that we need to increase pirate activity in order to decrease this tropical cyclone intensity. So what about third variables? What about global warming? It is common sense that piracy has no effect on tropical cyclones. Therefore, this article proves that correlation does not always necessarily mean causation. The moral of the story is that we need to be hypersensitive to correlations and causations that we see in the media every day.